In this video, we'll learn how to make a circuit using a few simple materials. Let's go over the things that we'll need. We'll need cardboard or cardstock, a battery terminal to house our batteries, the batteries themselves, conductive tape, this tape is made out of copper, wire strippers, scissors, electrical tape, and LEDs, or light-emitting diodes. Let's go over some of these components in more depth. There are a few different kinds of battery terminals that you can use for this project. This one has an on-off switch and a plastic case which completely encloses the two AA batteries. This terminal also has a switch, which is this metal piece. When it is open to the side like this, the circuit is open and therefore power is not available, and when it's closed and touching the spring, power is available. This terminal is used for a 9-volt battery instead of two AA batteries like the other two. If you're using that 9-volt terminal or something like this, which is for two AA batteries and doesn't have a switch, make sure that students are disconnecting the batteries entirely while working. Light-emitting diodes, or LEDs, will be providing the light in our circuits. You can see that these work best at a voltage of 3.0 to 3.2 volts, and since we'll be using two AA batteries, which each have 1.5 volts, that's 3.0 volts in the circuit, which is perfect. LEDs have a short end and a long end. We'll talk more about that later, but the direction is very important. So make sure that students are able to identify which end is long and which end is short. For this project, we're going to be bending the legs of the diodes so that they can sit flat on the cardboard. So in order to do that, you can first bend out and then bend both legs in the same direction so that it kind of looks like a person sitting with their legs splayed out in front of them. You can also use the table to help make sure that the legs are straight. Next, let's talk about wire strippers. These wire strippers have a lock. In order to open the lock, squeeze the handles and move the lock out of the locked position. To lock it again, squeeze the handles and move the lock back. It's always a good idea to keep it locked when you're not using it. The scissor-like portion closest to the pivot point is used to cut wires, and these jagged teeth are used to strip wires. Before cutting or stripping wires, always make sure that there's no power flowing through them. If your battery terminal has a switch, you can turn it off, or you can simply remove the batteries from the terminal to make sure that no power is flowing. Select the length that you want to cut, and then use the innermost part of the wire strippers to cut the wire. This wire is very thin, so we're going to use the smallest gauge, which is gauge 22, to strip the insulating portion off of the wires. So insert the wire into the divot, squeeze the handles, and then pull with some force in order to remove the insulation from the wire. And now you've got some exposed wire that you can use. All right, let's get started. The first thing we'll do is attach our battery terminal to the cardboard. Load the batteries into the terminal, making sure that the negative end and the positive end are facing the right direction. If your terminal is encapsulated, go ahead and close it. And make sure that the switch is in the off position. Fold over a piece of electrical tape and use it to attach the terminal to the cardboard, making sure that if you do have a switch, it's facing up and not down so that you can access it. Next, we'll start to lay down some tracks of copper tape, or conductive tape. A conductor is something that electricity can pass through easily. An insulator is something that electricity can't pass through easily. Copper is a really good conductor, a lot of metals are. This tape is conductive on both sides, meaning even the sticky side will easily conduct electricity, which makes it really good for this project. Cut two small lengths off like this to form the beginnings of your tracks, and then carefully peel the paper backing off of the copper tape. This is basically foil, and so it wrinkles and folds really easily, so be careful. Lay one strip down for the black wire coming out of the terminal, and another strip down for the red wire. The different colors indicate different polarity. The red wire is positively charged and the black wire is negatively charged. This just means that current flows from the red wire into the circuit and back through the black wire. Electricity cannot flow through a circuit if there is a break in that circuit. That's how a switch works. It basically temporarily breaks the circuit until you turn the switch back on. Now we're going to attach the wires to the 2 copper tracks that we've laid down using some more copper tape. Cut off 2 small sections, carefully peel the paper backing off, and then, being as neat as possible, tape the 2 wires down onto the tracks. Make sure that all of the exposed metal part of the wire is covered by the copper tape, and it's a good idea to include a bit of the insulation under the tape as well, just to keep things in place. Press down tightly to make sure that the adhesive holds, and do the same for the red wire as well. Next, let's add our first LED into the circuit. A diode is any electrical component that has 2 terminals and that only allows electricity to flow through in one direction. The longer end of the diode is the positive end of the diode, so that one needs to touch the track that is connected to the red wire coming out of the battery terminal. The short end of the diode is the negative end of the diode, which means that it needs to be connected to the track, which is connected to the black wire coming out of the battery terminal. It's always a good idea to just turn your circuit on and touch the legs to the track before you actually tape the diode down in order to make sure that you have the direction correct. Now that we've checked the direction of the diode, we can tape it down. I'm first going to make the tracks a little bit longer. You can do this by just taping additional tape down onto the track. You'll notice that these tracks will never touch. If they do, we'll have what's called a short circuit, which I'll go into more later. Once again, let's turn on the terminal and double check that we have the direction correct. Cut 2 small pieces of conductive tape and use them to attach the ends of the diode, or the terminals of the diode, onto the copper tracks. Be sure to press down on the tape tightly to make sure that the adhesive holds. Optionally, you can use some electrical tape to further stabilize the LED diode, but usually the conductive tape is enough to hold it in place. The insulating tape, or the electrical tape, can touch both tracks at once because it doesn't conduct electricity very well, therefore it won't cause a short circuit if you bridge the tracks with it. It's always a good idea to test our components after we add them, and it looks like this one's good. You can see that I'm wiggling around the diode and the 2 wires just to make sure that they stay in place. If the lights flicker, that's a sign that something is loose and we need to reconnect it. You can see here that I'm using a piece of conductive tape to bridge the 2 tracks and causing a short circuit. There's less resistance for the electricity or the current to simply flow through the copper that I'm holding down. Therefore, it never actually goes through the LED. We'll add our second LED, and I'm speeding this up just because we already know how to do it. Let's test out our circuit, and both lights work. Let's go over a few things that you might talk about when checking for understanding with your students. First off, what's a switch? A switch is a component that can close a circuit in the on position in order to allow current to flow through it. When the switch is off, the circuit is open and current doesn't flow. You can also talk about positive and negative in terms of circuits. The red wire is the positive end of the battery terminal, and the black wire is the negative end. You can also talk about conductors, such as the copper tape that we laid down, or the metal terminals of the diodes, versus insulators, such as electrical tape or the cardboard that we're connecting these things to. Conductors allow electricity to flow, insulators don't. LEDs are light-emitting diodes. They're also polarized. They have a short end and a long end, the short end being negative and the long end being positive. Current flows from the positive end of the battery terminal all the way through the circuit and back through the black end, or the negative end of the battery terminal. This is also a parallel circuit, meaning that each time that we have a diode along the circuit, current branches to go both through the diode and continue through the rest of the circuit. Happy building!